Hello, my name is Ardi and we are going to solve this problem here, E3.22. So the question is find V0 in figure E3.22 using mesh analysis. Okay, we are asked to use mesh analysis, so let's just draw the loops here. Let's name this loop here as I1, and then this loop here as I2, and then this loop here as I3. Okay, that is good. And we need to do KVL for each loops. Okay, let's exactly do that. Okay, maybe let's split this into halves so we get some space here. So let's do start from KVL on the loop I1. KVL at loop I1. Okay, KVL said that the sum of the voltage in a loop will equal to 0. Okay, and let's start by this 10-volt voltage source. The current here flowing from the negative terminal to positive terminal. So our sign will be negative, and then the magnitude will be 10. Okay, and then plus we will have this 2 kilo ohm resistor. We just write it 2, but this is a resistance. We need voltage, so we multiply it by the only current that pass through it, which is I1. Okay, and we don't need to convert the kilo ohm into ohm because we know that I1 will be in milliampere. Good. And then the next one, we will have this 3 kilo ohm resistor. So we'll have 3I1 here. And then we will have 4 kilo ohm. However, this one has two currents that pass through it. I1 going down and I2 going up. So we will have to multiply it by I1 minus I2. I1 came first because we are working on I1 here. So we'll have I1 and then minus I2. Good. And then we will have that 3 kilo ohm resistor. And same case here, we will have 3 kilo ohm. But I1 going down, I3 going up. So we will have I1 minus I3. Good. And then the last one, we will have 0.5 Vx. Okay, I need some space. Let's move this line. And so we will have Vx here. Okay, 0.5 Vx. So we'll have plus 0.5 Vx. All of that will equal to 0. Good. Now, let's see what is Vx here. Vx, okay, maybe let's do it here. Vx, we can calculate Vx, right? The positive terminal is here. So we need the current that goes there, right? So we will have I2 and then minus I3, then multiplied by the resistance, which is that 6. Good. Okay, now we can plug this Vx into this one. Okay, I think we just need to erase this, I think. Okay, let's plug that Vx into this one here. So we will have that is equal to 0.5 times 6. That will be 3, right? So we'll have 3, then multiplied by I2 minus I3. And all of that will equal to 0. And let's just copy all of this previous term. Like this. No. Good. Okay, let's just copy it first. Here. And we also have this term here. I1 minus I3. Good. Now we will have I1 comes from this 4 term here. 2 plus 3, which is 5. 5 plus 4, which is 9. 9 plus 3, which is 12. So I will have 12 I1. Okay, now I2 comes from here. Minus 4 plus 3, which is minus I2. Which is good. And then I3 comes from here. Minus 3 and minus 3. So I will have minus 6 I3. All of that will equal to 0. Good. Now let's save this as equation number 1. Good. And now what else that can we do? We do another KVL, but this time at loop I2 here. Okay, let's do exactly that. KVL at loop I2. KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's start from this 4 kilo ohm, and currently we are working on I2, so for I2, but then I1 here flowing to the opposite direction. So I have minus I1, and then plus 4, but the only current that pass through it is I2, so we'll have I2, and then this voltage here, because the current is flowing from the negative terminal to positive terminal, the sign will be negative. So we'll have minus here, minus 12. And finally, for the final component, we will have 6 kilo ohm. But this one multiplied by I2, but here I3 is flowing to the opposite direction. So minus I3. Okay, and all of that will equal to 0. Good. Now, I1 is only comes from this term. So we'll have minus 4I1. And then I2 comes for many places here. 1, 2, 3. So 4 plus 4, that will be 8. 8 plus 6, that will be 14. So we'll have 14 I2. And then we will have minus 6 I3. Good. Minus 12. Let's move it to the right hand side. So we'll have 12 here. Okay, let's save this as equation number 2. And now we need KVL at loop I3. But maybe let's erase this first because I need some space. Okay, let's do the third KVL, which is at loop I3. Okay, let's do exactly that. So we need to do KVL at loop I3. Okay, good. Okay, remember that KVL said that the sum of the voltage in a loop will equal to 0. And let's start from this dependent voltage source. So we will have minus 0.5 Vx. But then immediately we know that Vx is this term here. So let's multiply that. So we'll have 0.5 multiplied by 6, that will be 3, right? So we'll have 3, and then multiplied by I2, then minus I3. Good, and then we will have this 3 kilo ohm resistor. So we'll have 3 multiplied by I3, and then here I1 is flowing to the opposite direction. So we'll have minus I1. Good. And now we will have this 6 kilo ohm resistor. So we'll have 6 multiplied by I3, but then I2 is flowing to the opposite direction. Good. And finally, we will have this 6 kilo ohm. Here we will have 6, and the only current that pass through it is I3. All of that will equal to 0. Good. Now we will have this one. So we'll have minus 3I1. And then for I2, it comes from this one, minus 3, and then minus 6, which is minus 9. Minus 9I2. And then what else that we can do? We will have I3 here. We will have 3. And then plus 3, we will have 6. And then 6 plus 6, that will be 12. And then 12 plus 6, that will be 18. So I'll have 18 I3 here. And all of that will equal to 0. Good. Okay, I think we made some mistakes here. This should be 10. Yeah, let's move this minus 10 to the right hand side. So we'll have 10 here. So we'll have this one is 10. And this one will be our third equation. Good. We have now 3 equations with 3 variables. We should be able to solve this, right? Okay, let's use our calculator to solve this. Let's set our calculator as equation solver, which is number 5. And then let's plug in the coefficient for 3 variables, which is number 2. So we'll have 12, then minus 1, and then minus 6, and then that will equal to 10. Good, and then we will have minus 4, then we will have 14, then we will have minus 6, and all of that will equal to 12 here. Then what is I3? I3 is this one, so we have minus 3, minus 9, and then 18, and then 0. Good. So now we will have the value of I1. Okay, what is I1? I1 is 1.564. 1.564, and the unit will be in milliampere, right? Because this is volt in kilo ohm. And then what is I2? I2 will be this one here, 1.802. 1.802. So the unit will be in milliampere. And then I3, that will be 1.162. 1.162, and the unit will be in milliampere. However, the question is asking about V0, which is this one here. What is V0? V0 is just I3 multiplied by 6. So we'll have 1.162 multiplied by 6, and let's calculate that. So we'll have 1.162 multiplied by 6. And we'll have 6.97. So we'll have P0 is equal to 6.97. And the unit, because this 6 is kilo ohm and this one is milliampere, we'll have the unit is volt. And this is the final answer for this question here. Hopefully I did not make any calculation mistakes. Thank you for watching. And then see you in the next video. Bye bye.